Hello and welcome to this video in which we shall be discussing horizontal asymptotes. So a horizontal asymptote is a determinant of the end behavior of the function. So if you have a rational function looking like this, for example, we're interested in what the value of the function approaches towards the edges. So how do we figure this out? We plug x as a very large number. So as positive infinity or negative infinity, it doesn't matter. We just choose any random large positive or negative number and we plug x. Now, there is something to bear in mind when we're doing that. For example, if I plug x as a million and I add 8 to that because we have x plus 8 in the numerator. So we get 1,000,008. Of course, 1,000,008 is roughly the same as 1 million. So this 8 does not really add a value to my number. You cannot say I have $1,008 in the bank. This doesn't make sense. You just say I have $1,000,000 in the bank, right? So this 8 is negligible because it's a very small value compared to this number. So this is approximately equal to 1 million anyway. We do not write this number. What does that tell us? This tells us that if we have a very big number added to or subtracted from a very small number, we just ignore the small number. So in this case, we're going to ignore the 8. And for the denominator, a similar concept occurs. Let's say we put x as a million, and we have x squared plus 10x plus 24. So for x squared, we get a million millions. So 1 million times 1 million, so we have 12 zeros. Plus 10 million plus 24. Of course, we all agree that the 24 does not really add anything. But furthermore, compared to a million millions, 10 million is insignificant. It's just the same as saying, as comparing 10 to 1 million. So 10 million and a million millions are the same as comparing to 10 and 1 million. So 10 is insignificant compared to 1 million. Therefore, 10 million is insignificant compared to 1 million millions. So again, this is also rejected or neglected. So the only term that matters here is this term. So we can just cancel these out. So this is very nice because we're simplifying the expression in a sense. So our new expression becomes f of x equals x over x squared. Why is that? Because we ignored the 8 on top, and we ignored the 10x and the 24. We only considered the x power 2 because the other two terms are insignificant for large values of x. Now, we want to simplify this expression. So if you divide x by x squared, you get 1 over x. And again, we're plugging x to be a very large number. So 1 over a million. What's 1 over 1 million? So if you have £1 or $1 and you're dividing it among 1 million people, what does each person get? Almost nothing, because you're dividing 1 by 1 million over a huge number of people. So this is equal to 0. So the end behavior of the function is equal to 0 because you have 1 in the numerator and 1 million in the denominator. Therefore, we have one horizontal asymptote with y equals to 0. Why is it y equals? Because it's a horizontal line, and you should know that the horizontal line has the equation y equals 5, y equals 4. So it has to be y equals something, and it's equal to 0 here because of this expression. I know this might seem a little bit complicated. We'll do a lot of examples in this video until you definitely know how to figure this out. So anyway, this is the correct answer here. Let's try another one. So again, the idea is we're plugging a very big number into x, and this makes everything insignificant except the highest power of x. So if we put 1 million here, we get 4 million millions versus 50 millions. Of course, this is insignificant, and the 100 is insignificant as well. In the denominator, we have 6 million plus 21, so this becomes insignificant as well. Now that we've rejected all the insignificant terms, we have 4x squared over 6x. Let's simplify. So this becomes 2 over 3, and these become x over 1. So we have 2x over 3. So what happens in case of putting 1 million here? You get 2 million over 3. So what if we put 100 million? We get 200 million over 3. But if we put a million millions, we get 2 million millions over 3. So the larger value that I put in x, the larger result I get. In this case, there is no horizontal asymptote because the larger that x gets, the larger that y gets as well. So as x approaches infinity, y approaches infinity as well. And in this case, we do not have a horizontal asymptote. So in this case, there is no horizontal asymptote. Okay, so in this case here, we want all the horizontal asymptotes of the following function, and they gave it to us in factored form. The advantage of factored form here is that you can just cross these out and start with this expression. And then we plug x as a very big number. Of course, when we do that, this is neglected, and we get 1 over 2x. So again, this is the case of dividing 1 by 2 million or 200 million or 2 million millions. And if you're dividing 1 over such a huge number, you get 0. So y equals 0. And in this case, we have one horizontal asymptote, and the equation is y equals 0. Here we have a function 2x minus 4 over x plus 5. You can just maybe expand, so we get 2x minus 8 over x plus 5. And then we said we reject anything that is not the highest power of x. So we have 2x and we have 8. So we can just reject the 8. Here we have x and 5, so we reject the 5 as well. So we end up with 2x over x. If we simplify, we get 2. So no matter what the value of x is, we're going to get 2 at the end. So the horizontal asymptote here has the equation y equals to 2. We see that we have a lot of different cases. I'll just keep solving, and then at the end, I'm going to give you a summary of the different cases that we can get. Let's look at this problem here. It's nice of them to have factorized for us. We can just cancel these out from the beginning. And we have 3 times 5x plus 3 over 2. And in this case, if we put 1 million for x, we get a huge number. 5 million plus 3. Even if we cancel out the 3, we still have 5 million times 3 over 2. So as x gets very large, in this case, y gets very large as well. So you might have started to notice a pattern. If we simplify and we end up with x over something, x over 2 or whatever, this means that as x approaches infinity, y approaches infinity. If we get something over x, 3 over x, this means that as x approaches infinity, y approaches 0, because we're dividing 3 by a huge number. If we have an expression like 2x over 5x, we just cancel out the x's, and we get 2 over 5. So as x approaches infinity, y approaches 2 over 5. So this is the summary of the 3 cases that we're facing in this exercise. Either we have x on top or x at the bottom, or 2 x's that can cancel out. And for each case, we know what to do. So in this case here, this expression here is similar to the first case. where we have y equals infinity, so no horizontal asymptote. Okay, let's do a couple more. So here it's not factored. So let's apply this idea of ignoring the smaller terms. So we have 3x power 2 and 15x. If we put a million, we get 3 million million in the first and 15 million in the second. So 3 million millions are, are huge compared to 15 million. We just cross this out. And in the denominator, we can cross these out as well using the same logic. So we have 3x squared over 10x squared. If we cancel out the x power 2 and the x power 2, we end up with 3 over 10. So y equals 3 over 10. As x approaches infinity, y equals 3 over 10. Let's try another one. So we have here 2x minus 6 and x plus 1. You can ignore the smaller terms. We get 2x over x. You can cancel out the x. So y equals to 2. In this case, we have 15x minus 6 over x squared plus 4x minus 45. You can ignore the smaller terms. We get 15x over x power 2. Now, if we cancel out 1x, we get 15 over x. So this is the case of dividing $15 over 1 million people. Y equals 0. Each person gets almost nothing, so y equals 0. We have factored form here, and there's nothing that cancels out. So let's expand here because there's nothing to cancel out, and you want to figure out the highest power in each case. So let's just expand. You get 6x power 2 plus 4x over 3 times 2x power 2, first times first, first times second, so plus 4x minus 9x, and finally minus 18. Now, we said that we don't care about anything except the highest power. So let's just reject this, this, and this. And we are left with these two expressions here, 6x power 2 over 6x power 2. We can cancel these out, and 6 over 6 equals 1. So y equals 1 is our final answer. For this expression, we can just cancel out all of these. We get 50x power 2 over 15x power 2. And these will cancel out as well. So 50 over 15 and divide by 5, you get 10 over 3. So y equals 10 over 3. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.